When I look at the characteristics that are expected of people in the world of work today, and look at our I3 project and the laser model, they all align so very well. We're expecting young people to demonstrate that they can speak and write and use numbers and certainly problem solve, process information, use technology, and work in teams. It's a perfect match. Done correctly, young people will be ready for the world after they graduate from school.
I would say the Smithsonian curriculum is really powerful for kids because the materials are very accessible to them. The lessons are scaffolded so that they feel very successful with each lesson, and as the lessons progress and get harder and harder, they're able to grasp what they're supposed to be doing with the materials. It allows you to connect those big abstract concepts to something that's sitting in their hands.
They love science, they love the hands-on, the interaction, the chance to talk about everything, to draw about, draw what they see, draw what they do, and it's a very good learning experience for them and for me. Having the materials and everything, given, it makes it easy to teach.
Allowing the children to explore and engage in learning, I think that has always been the key to education. 10, 20 years from now, they may not remember everything about electric circuits, but they'll know, oh, this is a conductor. They know this is the insulator. A lot of the material that they can learn here, it's applied more to real world as they get older, and then they can actually explore careers.
That's telling us that the density of air is 1 gram per milliliters cubed.
When science time comes, the children are excited. They can't wait because they know that it's going to be time to work with their friends, time to talk with each other, time to learn some exciting material, and the Laser I3 project has been very instrumental in that because we have the materials, we have access to it. We've been trained, we've had incredible professional development, and I can take the knowledge I've learned from those different workshops and bring it into my classroom, and the kids benefit greatly.
The training that the Smithsonian offers during the summer is fantastic. You come in and they actually teach you what you're going to be teaching your students throughout that school year. And so it's really nice because you're doing hands-on stuff. You're actually making a book that you're going to use to teach your children with.
Ooh, I love the training. I actually got a chance to go for the full week and actually go through each one of the lessons and making sure that we understood exactly how to do each lesson, as well as we had the level 2 deepening understanding so that we understood the background behind the units we were teaching for the kids. So that was very good for adult learning purposes. So it was very good training. It was one of the best I've ever been to.
The level 1 training is really wonderful because it allows teachers to do each step of the kit as an adult learner. So they're building science content as they work through the kit themselves, but they're also developing a comfort with how to manage materials and what it's going to look like when they take it back to the classroom.
The Laser I3 training that we've had during the summer that prepares the teachers with the science kits is crucial. It's so important because it gives us the experience. We're learning it firsthand, and then we're able to teach it to the students. But I think that's crucial to be an effective science teacher is you have to learn it first and you have to experience it.
Science is important because it's the direction that our world is going. People going into the workforce are expected to understand technology and science and math. That's where the jobs of our future are. It's really important that our kids are getting these skills. And when they're learning science, they're doing all of those things.
One of the really great things about the Smithsonian curriculum is that we actually use tools that real scientists use. The curriculum also really pushes the language of scientists to observe, scientists share, scientists collaborate, pushes notebooking, which is something that real scientists do.
When we do the experiment, we talk about it, we think about it, and we write about it. And we predict something and we write it in our journals and we see if our prediction is right.
Wow. So I think that this inquiry-based science is really going to build the foundation for them So when they get to high school, they might be more willing to take classes like physics or chemistry, where otherwise, if they've only had kind of negative experiences with science, like, oh, this is boring, I read a book, they're not going to want to take those, higher level science classes. So I think that this will just really set the stage for them and prepare them for life.
But it's not really lighting it.
We saw instant results in our test scores, a double-digit increase in our intergrade state performance for our 5th grade students, and that has sustained. It has continued to be increases of 8, 9, 10, 12, and up to 19% one year.
1, 2, 3.
They're finding answers themselves. They're finding, ways to go about the scientific method. Those are things that don't only get used in science. They get used every day, deductive reasoning, making inferences. And if you can do that in one subject, you can do it everywhere. So inquiry-based learning is really giving them the opportunity to hone those skills. After 16 years of teaching, I've sort of found where I fit. And that part feels really cool. And to hear my name 20 times in a class of, come see this, that just makes your heart sing as a teacher, right? That's what you want to see.
So I see that the level of engagement has increased with the STC kids because when they're experimenting, they're more engaged, they're more willing to ask questions, willing to talk about what they're experimenting, whereas when they're just reading about it, they're not willing to have the same kind of focus or attention to it as they are when they're experimenting with it. Seeing them working on the experiments and seeing the learning happen without them even realizing it's happening. It's a joy to me to see the light bulb go off on their head, and all based on them doing experiments with the STC kit.